Graphing trig functions. All right, let's graph a sine wave. So what we're going to do is we're going to take a look at the unit circle. And on the unit circle, we actually have three variables. We have the x, the y, but we also have the angles. What we're going to do is we're going to plot the angle and the y value of the ordered pair in the rectangular coordinate system. So let's go ahead and do that. First, we'll start with 0 radians. So the angle is 0 radians and the y value is 0. So 0 radians and the y value of 0, that's that ordered pair. Next, I'll have pi over 6. Pi over 6 radians, and I'm going to graph that with 1/2. So pi over 6 radians on the x-axis, 1/2 on the y-axis, halfway between 0 and 1, and that's a second point. I'm just going to continue like this. So pi over 4, I'm going to graph the square root of 2 over 2, which is like 0.70 or 0.71. And then for pi over 3, I'm going to graph the square root of 3 over 2, which is 0.86 or 0.87. And then for pi over 2, which is that 90-degree quadrant angle, the y value is 1. So I'm going to graph pi over 2 on the x-axis, 1 on the y-axis. This ordered pair right here. I'm going to do the same thing through the second quadrant. 2 pi over 3, square root of 3 over 2, 3 pi over 4, square root of 2 over 2, 5 pi over 6, 1/2, pi and 0. So I'm back to an x-intercept here, pi, because the y value of that ordered pair is 0 there. So 7 pi over 6, we're at negative 1/2. 5 pi over 4, we're at negative square root of 2 over 2. 4 pi over 3, we're at negative square root of 3 over 2. And at 3 pi over 2, we're at negative 1. At 5 pi over 3, now I'm going to be at negative square root of 3 over 2, which is above negative 1. And then I keep going. I get 7 pi over 4, negative square root of 2 over 2. I get 11 pi over 6, negative 1/2. And then I'm back to 2 pi, and I'm back to 0. This is what the graph would look like. And all you have to do is connect all these with a smooth curve, and you'll get this y equals the sine of x. When you're graphing it, you don't have to go through all these angles. We're going to focus specifically on the quadrant angles. So these are the quadrant angles here. 0, 0, pi over 2, 1, pi 0, pi 0 is over here. 3 pi over 2, negative 1, 3 pi over 2, negative 1, and then 2 pi 0. The reason we're focusing on these is because these are points on the graph that are significant. We have 1, 2, 3 x-intercepts where the y value is 0, and we have a maximum and a minimum value. For the sine function, you need to graph 3 x-intercepts, a maximum and a minimum. A function f is periodic if there exists a positive number p such that when you apply the function to t plus p, you get the exact same number as if you apply the function to t. And this is for all t in the domain of f. The smallest positive number p for which f is periodic is called the period of f. Specifically for the sine function, the period of the sine function is given to us if we know the coefficient of the variable x that's being multiplied to give us the angle. So we're taking the sine of an angle, and if that angle is a variable x multiplied by some constant, then the period is going to be equal to 2 pi over that constant. And if you take a look here, in this case, the constant would be 1, and this is the graph when the constant is 1. If the constant is 1, then the period would just be 2 pi over 1, or 2 pi. And you see 1 full period of this graph is 2 pi units. So the period of a sine function is 2 pi over the coefficient of the variable x. And here's an example. So for this example, here's 3/4 of x. So the coefficient b of x is 3/4. So 2 pi divided by 3/4 is going to be done by flipping the bottom fraction and multiplying. 2 pi divided by b is the period. We keep flip change. We get 2 pi times 4/3. And then we multiply, we get 8/3. So the period of this sine wave is 8 pi/3. We'll do one full cycle of 3 x-intercepts, a maximum and a minimum. We'll do that within 8 pi/3 units. Let's go ahead and graph it. All right, so the period is 8 pi/3. What we want to do is we want to figure out what 1/4 of that period is. We want to break it up into quarters so we can see all the quadrant marks. I'm going to divide this by 4. This is the period divided by 4. Once again, I keep the top fraction the same, 8 pi/3, but I'm going to flip the bottom fraction over and multiply. So that's 8 pi/3 multiplied by 1/4. That's 8 pi/12, and when you reduce that, you get 2 pi/3. So here's 0. So I'm going to add 2 pi/3 to get the first quadrant mark, which is here at 2 pi/3. That's 0 plus 2 pi/3. So from that x-intercept, I know here is where I'm going to have a maximum. The next value on the sine function is going to be another x-intercept. It's going to be 2 pi/3 units away from here on the x-axis. So add another 2 pi/3, and here's where I have an x-intercept at 4 pi/3. The next point on the graph of the sine is going to be a minimum, and it's going to be 2 pi/3 units away from this. So I'm going to add 2 pi/3 to this, and 4 pi/3 plus 2 pi/3 is 6 pi/3, which you can reduce to 2 pi. At 2 pi, we're going to have a minimum. And then the last point that we need to graph is that last x-intercept, and it's going to be 2 pi/3 units away from 2 pi. So 2 pi was 6 pi/3. If I add another 2 pi/3, I get 8 pi/3, which is the period. So this one full cycle is completed in this period. So I just connect these dots, and these are my 5 key points that I can graph to get this sine wave. So I have the 5 key points, the 3 x-intercepts, and the maximum and the minimum, and that is the graph. All right, so what happens if you have a coefficient in front of the sine? So now, not only is there this b being multiplied by x, but there's also a as a coefficient of the sine function itself. The maximum value of y for the graph of y equals a times the sine of bx is the absolute value of a. So this graph will only go as high up as the absolute value of a, and the lowest point on the graph will be the opposite of the absolute value of a. So the amplitude is this maximum value. All right, let's try one. Let's try this one here. So this one not only has that 3 in front of x, 3 being multiplied by x, which is going to change the period, but it also has this 4 in the front of the whole thing, which is going to change the amplitude. Let's find the period first. Remember, the period for a sine function is 2 pi over the coefficient of x. So that's going to be 2 pi/3 for the period. I need to find out what 1/4 of this is. So I'm going to divide this by 4. So I'm going to find 1/4 of the period as 2 pi/3 divided by 4, which means I'm going to flip the bottom and multiply. This is going to give me 1/4 period of pi/6. So starting at 0, starting at the origin here, I'm going to keep adding pi/6 until I get all the way over to 2 pi/3. So I add pi/6. So I'm going to add another pi/6. So this is 1 pi/6. Next one will be 2 pi/6 or pi/3. So to this, I'm going to add another pi/6. So this was 2 pi/6. I'm going to add another one to make 3 pi/6. 3 pi/6 is pi/2 when you reduce it. I'm going to add another pi/6 to this 3 pi/6 to get 4 pi over 6, which is reduced to 2 pi over 3. These are the places where I'm going to have my intercepts. So there's going to be an intercept here, here, and here. And also the places where I'm going to have my maximums and mins. So I'm going to have a maximum here and a minimum here. So let's go ahead and find out what those maximums and minimums are going to be. That's where we look at the amplitude. How high up am I going to go? Well, the amplitude is the absolute value of 4, which means I need to go 4 for the maximum and 4 for the minimum. Let's go ahead and graph these points. There's the first intercept, which occurs here at the origin. There is the first maximum, or the only maximum on the interval, which occurs here at pi over 6. There is the next intercept, which occurs at the halfway point here at pi over 3. There is a minimum now that occurs at the 3/4 mark, pi over 2. At -4, we have a minimum. And then the last point is the next intercept, and it occurs at the very end, at the end of the period, which is at 2 pi over 3. So we have these 3 x-intercepts, a maximum and a minimum. That's one period of this sine wave. I just connect them. The graph of y equals a times the sine of bx minus c is the graph of y equals a times the sine of bx, which we just graphed, but it's shifted horizontally, c divided by b units. So c divided by b units is the horizontal shift. The number c over b is called the phase shift of the graph. So it shifts the phase of the graph. All right, let's try one. Here's one. Graph the function f of x equals 4 times the sine of 2x plus pi over 3. So I'm going to find the phase shift by setting this angle, 2x plus pi over 3, equal to 0. That'll give me c over b. So I just set that equal to 0, and I solve it by subtracting pi over 3 from both sides. That's the negative c. And then I divide both sides by 2, and I get x is equal to negative pi over 6. This is the phase shift. This would be your c over b that you were looking for, the phase shift. So instead of starting at the origin, I'm going to start at that phase shift, negative pi over 6. I still need to figure out how long the period is, what's the length of the period, and I still need to chop that up into quarters. So I find the period length by dividing 2 pi by b. So the period is pi units long. I just need to divide that into 4 parts. So I'll have pi over 4 as the quarter of my period. I'm going to start with negative pi over 6, and I'm going to add a quarter of pi each time. So negative pi over 6 plus pi over 4. I need a common denominator. The common denominator here would be 12. Pi over 6 is 2 pi over 12, and pi over 4 is 3 pi over 12. And then I just add them. When I add them, I just get pi over 12. This is negative 2, this is positive 3. So I get positive 1 pi over 12. That is the next quarter mark. So at this point, I have an x-intercept. At that next quarter mark, I'm going to have a maximum. All right, then I'm looking for the next quarter mark. So I'm going to add that quarter period, pi over 4. I'm going to add that to pi over 12, but I'm adding it with a common denominator. So I'm actually adding 3 pi over 12. So pi over 12 plus 3 pi over 12, which is that quarter period, is going to be 4 pi over 12, which you can reduce. 4 pi over 12 is just pi over 3. So the next quarter mark is at pi over 3. Pi over 3. All right, so then I'm going to add another quarter period to that. So I'm adding another 3 pi over 12. Well, 4 pi plus 3 pi makes 7 pi over 12. 7 pi over 12 is the next quarter mark. Then I'm going to add another 3 pi over 12 to that. So adding another 3 pi over 12 gives me 10 pi over 12. 10 pi over 12 reduces to 5 pi over 6. So 5 pi over 6 is that last quarter mark. So there I have my 5x values for my intercepts and my extrema, my maximums and minimums. So I'm just going to go ahead and figure out what the amplitude is. Well, looking at the amplitude, it's the same as before. It's 4. The amplitude is just the absolute value of 4 there. So I'm going to go 4 high and 4 low. I'm going to go up to positive 4 on the y-axis, down to negative 4, and I'm going to graph these points. So at the beginning, I'm going to have at negative pi over 6 an x-intercept. And then at pi over 12, I'm going to have a maximum. And then at pi over 3, the next quarter mark, I'm going to have an x-intercept. And then at 7 pi over 12, the next quarter mark, I'm going to have a minimum. And then at 5 pi over 6, the end of the period here, I'm going to have my last x-intercept. So those are the quarter marks there, and then I just go ahead and connect them with a smooth curve to graph the sine wave. Now this doesn't just work for the sine. We could do the exact same thing with the cosine. What we did for the sine is we took these angles and we graphed the y value of the ordered pair. But instead of graphing the y values, we could graph the x values of these ordered pairs instead with these angles. And if we did that, for instance, we'd get 0, 1, which is up here. We'd get pi over 6 square root of 2 over 2, pi square root of 2 over 2. And the ones we'd actually want would be the quarter marks. Pi over 2, 0, pi negative 1, 3 pi over 2, 0, 2 pi 1. Those are the ones we'd actually want. But we'd get these kind of points here if we did that with the x values instead of the y values. So on the x-axis, we still have the angles in radians. But on the y-axis now, we're graphing the x values of these ordered pairs. This, if you connect the dots with a smooth curve, will give us the graph we call the cosine function. Very similar to the sine function. This is the cosine function. And it works the exact same way as the sine function does, except instead of having the 3 x-intercepts and a maximum and a minimum, this one has either 2 maximums or 2 minimums, 2 x-intercepts, and if it had 2 maximums, it'll have 1 minimum. If it had 2 minimums, it'll have 1 maximum. But basically, these would be the 5 points. 3 of the points will be extrema, either maximums or minimums, and 2 will be intercepts when you graph the cosine, 1 period. Let's graph 1. Graph the function 3 cosine 3x minus pi over 4. So once again, we're going to try to find the phase shift just like we did with the sine. So we set this equal to 0 and we solve it by adding pi over 4 to both sides and then dividing by 3. We get the phase shift to be pi over 12. So we can put that on the graph here. That's the phase shift. From here, we're going to add a quarter of the period each time. So first we find the period, which is 2 pi over b. 2 pi over this number, just like before. So 2 pi over 3 is the period. I'm going to divide that into 4 parts. 2 pi over 3 divided by 4 is pi over 6. And now I'm just going to take this pi over 6 and continually add it to pi over 12 until I get to the end of the period. I need 5 points. This is the first one. I need 4 more. I take pi over 12 plus pi over 6. I need a common denominator, which is 12. So that's pi over 12 plus 2 pi over 12. This is what I'm going to be adding each time, 2 pi over 12. So this gives me 3 pi over 12. And 3 pi over 12 reduces to pi over 4. So I put pi over 4 as my next quarter mark. Then I add in another 2 pi over 12, which gives me 5 pi over 12. That's my next quarter mark. I add another 2 pi over 12, which gives me 7 pi over 12. That's my next quarter mark. And then I add another 2 pi over 12 to finally make 9 pi over 12, which reduces to 3 pi over 4, my last quarter mark. All right, now that I have all the quarter marks, I just need to know the amplitude to figure out what my maximums and minimums are. So let me see, the amplitude comes from this number. It's the absolute value of that number, 3. So that means I'm going to go as high as 3 and as low as negative 3 for my maximum and minimum. The cosine starts at a maximum. So at pi over 12, I'm going to be up here at 3, the amplitude. Then at the next quarter mark at pi over 2, or sorry, pi over 4, I'm going to have an x-intercept. Then at the next quarter mark, 5 pi over 12, I'm going to be at the minimum. Then at the next quarter mark, 7 pi over 12, that's another x-intercept. And at the last quarter mark, 3 pi over 4, I'm going to be back at a maximum. All right, so this is what the cosine graph looks like when you connect these with a smooth graph. You get this curve right here.